This week we're looking at experimental designs. Experimental designs are really well suited to test hypotheses. Experimentation is an approach to research best suited for explanation and evaluation. The classical experiment has three major components: the independent and dependent variables, pre-testing and post-testing, and having an experimental and control group. Okay, let's take a look at variables for a minute. Independent variables are basically independent of any other variable. They're the thing that we're actually researching. So, for example, medication. Does it work or doesn't it work? The medication would be an independent variable, and we might be studying relapse or rates of depression or aggression or something like that to see if that medication works. So that would be the dependent variable. But the independent variable in that case would be medication. Dependent variables are dependent on the independent variable. So if the medication works really well, we're going to have reduced relapses and hospitalizations and decreased depression and things like that. So just to give you some examples of independent and dependent variables. So treatment, so there might be a cognitive-based treatment for criminal behavior, and we might be looking at recidivism. The treatment, the cognitive behavioral type of treatment would be the independent variable, and the dependent variable would be criminal recidivism. Let's say like a curfew law. Say there's a city where there's a lot of truancy in the school, so they decide to develop and use a curfew law, saying students need to be home by 9 or 10 o'clock on a school night, and then they'll look at truancy rates at the school. Independent variable being the curfew law, dependent variable being the school truancy. And then also we could maybe look at a law enforcement technique. They might have increased patrols, or people might be walking the beat in a certain area, high crime area, and they're going to look at the amount of arrests or the amount of assaults or things like that, or the amount of drug use in a certain neighborhood. So the new law enforcement technique would be the independent variable. The dependent variable would be the number of arrests. The next important consideration is the pre-testing and post-testing. Pre-testing is the way the dependent variable was before you interject the independent variable. So we're looking at relapse rates. We might use a depression score, a test. Recidivism, so the amount of rearrests. School truancy, so the amount of people that have been missing school before we put in the program. For the recidivism, before we use the treatment program. For relapse, before we use the medication. And then we do post-testing. So after we use the medication or the treatment or the curfew law or the new law enforcement technique, then we look at the dependent variable again to see if there's any improvement, and sometimes the independent variable actually harmed. So maybe there's even more depression, more relapses, more recidivism, more truancy, more arrests, and things like that because of the independent variable actually did more harm than good. So now let's say we want to look at the effects of a cognitive behavioral treatment program in reducing criminal thinking and recidivism. Say we'll take a prison population. They're right there. They're an easy population. We'll give them the group, and then we'll compare them against a probation group that isn't going to get the treatment, just standard probation, and we see a bigger reduction in recidivism with the prison group. This is all made up, but let's say we see a bigger decrease in recidivism with the prison group compared to the probation group. Is that, and let's say we publish that research, and what would people say about that? Would they say, oh yeah, this cognitive behavioral group treatment really seems like it works when you compare these two groups, because it worked in this group and didn't work so well in this group? Well, is it more to do with the two groups? Maybe these people learned their lesson or got other treatments in prison, or just a really good recovery-orientated type of supportive prison programming, and they just so happen to add this cognitive behavioral treatment, who's to say it's the cognitive behavioral treatment that is the reason why there was a decrease in recidivism compared to the probation group? So you really have to look at how you split up the two groups. So your experimental group is your group that is actually exposed to the treatment, so in this case the prison population or the prison group. And your control group is basically they're given a placebo, or they're given a kind of the basic treatment as the treatment as usual, or sometimes they're people that are where they're kind of in, they call it the waiting room, where they kind of just that standard treatment as usual. And the main thing is we want a good mix of people. So it may have been smart to take a random sampling of the people in prison, and they're given the actual treatment, and taking a random sampling of the people that are in probation, and they're given that treatment, and then taking a random sample of each also, and they're not given that treatment, and then to compare those two groups to see what the difference is in the recidivism rate. So the experimental group, just to recap, they are exposed to the independent variable. They are exposed to the treatment, to the program, to whatever we're studying. The control group is not exposed to the independent variable. They're not exposed to the treatment or whatever we're experimenting on. So another really important phenomenon to know about is the Hawthorne effect. The Hawthorne effect is basically people that are in a study. They may like the attention of the study. They might feel an obligation to rate themselves higher in the post-test because they enjoyed being part of this and being paid attention to, and things like that. Another important thing is placebo. So we oftentimes don't want people to know whether they're part of the control group or not. So a placebo is, so they might be given a medication. And a lot of times when you talk about placebos, we think about medication. So they're given this medication, and there's a 50-50 chance that it works or not. So the people going into the study, to be ethical, they know that there's a 50-50 chance that they're going to be given the treatment. So if you're doing a study on extremely aggressive or suicidal people, doing this type of study might not be ethical because there might be increased suicides and assaultive behavior in people that aren't given that medication or given that treatment. But a placebo is something that is a neutral. It's basically a neutral independent variable. It's something that isn't shown to work or not work. They basically call that the water pill or the sugar pill or whatever. But anyway, it's a dummy independent variable that causes the person to think that they're getting the independent variable or the treatment or being exposed to the curfew law or whatever it is, and they're actually not. So a placebo type of an experiment, the individual doesn't know if they're getting the treatment or being exposed to the independent variable. But in a double-blind experiment, the researchers don't even know who's getting the treatment or not. The people, it's a total random assignment, and the people that are actually doing the pre-testing and the post-testing, they're not sure who has getting the treatment or not. So that reduces some of the bias that could possibly come about in that type of research. So just a little more on selecting a sample. This might be one of the most important things you do in researching an independent variable. And probably the most important thing out of everything is making sure that your control group and your experimental group are basically as similar as possible. I mean, if you could clone your experimental group to have them be your control group, that would be the best, but that's impossible. So, I guess you look at twin studies and things like that, but For the most part, most experimental designs aren't doing twin studies, so we really want to make sure that our subjects are selected very randomly. You can have a target population, so you might be doing it on a prison population, but you really want to be as random as possible on who you select within your target population, so you have your two groups as similar as possible. And this is called random assignment. So they're randomly assigned to either the control group or the experimental group. There is no hand selecting who you're going to give the treatment to and who you're not going to give the treatment to. So making sure that you consider the threats to validity, whether it be internal, external validity, is really important. Some of the things that might be fairly common in experimental design would be something like a person who drops out of where they're, let's say you're assessing depression with a certain treatment, and they aren't getting any better, and maybe they're getting worse, so they're more likely to drop out and say, I want a different treatment. They might have been a person that was in the control group, or possibly they were in the experimental group, but the side effects of the medication just were too much, intolerable, too many adverse effects, so they decided to drop out. So there might be dropout rates that tend to skew the research, but there's a lot of just things like that we might not think of that could impact our findings. So the last thing I want to talk about are quasi-experimental designs. Quasi basically meaning to a certain degree, so it's an experimental design to a certain degree. It's not an experimental design, but it has a lot of experimental design characteristics. The big difference is there usually isn't a randomized control group. There may not even be necessarily a control group at all. They might get the control group from previous research and things like that, so they don't have their own control group. So they're basically picking the people that they want to be in their study, or they might randomly pick people to be in their control group, but they're not having randomly picking people to be in their experimental group, but they're might not have that control group, or they might not randomly assign people to that control group. You might use this in things like if they're not given the treatment, or for example, if they have a certain law enforcement strategy that they're going to use in North Minneapolis, where they're going to start walking the beat, and because it's too risky to not, or they want more boots on the ground type of thing, where it might not be good or feasible to have the control group because they would be more likely to be victimized, or for people on the medication, if they're real assaultive or suicidal and they assault somebody or kill themselves, then there becomes a real liability factor within the research, because hey, they weren't given the medication or the treatment that would have protected them from possibly doing those things. So getting back to it, a quasi-experimental design is like an experimental design, but the randomization of the sample just doesn't happen.